Assalamualaikum everyone. My name is Nabila Tasfia Rahman. This is the presentation video of our EEE 306 project. The project proposal was comparison between load flow using classical Newton-Raphson and simplified Newton-Raphson. Other group members are Nusra Subha binte Shakhawat, Muhammad Rafiqul Islam Rafi, and Sheikh Munim Hussain. This is the beginning of our project. Here the user can choose which operation he or she wants to perform. There are two options. These are user-defined networks and built-in networks. About them, our next presenter, Nusra Subha binte Shakhawat, will describe.
This is Nusrat Subha binte Shakhawat and I will be talking about the user-defined part of our app. First, the user has to input his or her own data into the Excel file named book12, which we are using for the user-defined part. The network we have already inputted here, the single line diagram of it is given here. So if we press the read bus data button, we can see the bus data, and similarly if we press the read line data button, we can see line data. Then we press the perform analysis button and perform the Newton-Raphson method analysis. Then similarly the simplified Newton-Raphson method analysis is performed. Note that these operations can also be performed separately. For example, if we do not press the read line data button because we do not wish to see the line data here, but then perform analysis the Newton-Raphson method, then it also works accurately. However, later we compare the two methods. The comparison parameters are number of iteration, time elapsed, and time per iteration. As we can see, the time elapsed is significantly lesser in simplified Newton-Raphson method, and the time per iteration in simplified Newton-Raphson method is almost halved. So we can clearly see that the simplified Newton-Raphson method is performing better than the Newton-Raphson method. We have also added a bar graph of time per iteration for users' convenience. Now we can see the different reports for the different components. For example, bus report. If we press the show bus report button, then the bus report is shown. Similarly, line report, load report, and generator reports are also shown here. Later, we see the abnormal reports separately. There is no buses outside voltage limit here. Generators and reactive limit are shown here. Some underloaded lines and cables and some overloaded lines and cables are also shown here for abnormal reports. Finally, total generation, total load, total losses, and mismatches are summarized in the summary report. This is the user-defined part of our app. Our next project will be talking about the built-in part. Thank you.
Assalamu alaikum. This is Muhammad Rafiqul Islam Rafi. Here is the built-in part of our project. We are calling it built-in because the bus data and line data that we used are predefined IEEE standard data. From this drop-down menu, number of buses can be selected. Here 4, 14, 30 and 57 bus system networks are designed. After clicking this read bus data push button, these data are loaded from an Excel file. The bus data and line data characteristics are similar with the user-defined part that is demonstrated earlier. These are the results obtained after solving a 30 bus system network using Newton-Raphson method and a simplified Newton-Raphson method. Now if we compare these results, we can see that our proposed method took more iterations but less time. This is the corresponding bar diagram that describes the above table graphically. Now this is the time required per iteration versus bus number plot. The blue line is for simplified Newton-Raphson method and the red line is for Newton-Raphson method. Here the bus number is 4, here 14, here 30 and here 57. In all cases we can see that our proposed method took less time. Now this is the time required for complete the process versus bus number plot. Here the red line is for simplified Newton-Raphson method and the blue line is for Newton-Raphson method. Here we can see that as the bus number increases, the time difference it becomes more significant. In all cases our proposed method took less time to complete the process. Our next project mate will talk about the analysis report.
I am Sheikh Munim Hussain. In previous slides, my other group mates showed Newton-Raphson and simplified Newton-Raphson methods and their solution after solving different networks. Here I will show different reports. It is an advantage of our project that after loading data, if we want to see any report, we can just do that just by clicking on the corresponding push button. Here we can see the bus report and generator report. In the next slide, we can see the load report and line report. Here, PF value positive means the load is lagging, and negative means the load is leading. Here we can see the abnormal reports. For the abnormal reports, we also can see the abnormal reports easily just by clicking the corresponding push button. We don't need to run from the first to get the reports. Here, for the data of 30 buses, all the generators are within reactive limit. So there is no row in the generators at reactive limit table. In the next slide, we can see summary report. Here the base power is 100 MVA, and we can see different active and reactive power and see the mismatches of different powers. Here we can see the equations used for Newton-Raphson method and used for simplified Newton-Raphson method. To recap, we will briefly say the flowchart of classical Newton-Raphson method and simplified Newton-Raphson method. At first, the input data will enter both of the methods, and then a Jacobian matrix will be created. For classical Newton-Raphson, Jacobian matrix is based on P and Q, and for simplified Newton-Raphson, Jacobian matrix is based on the current value. We will make different iterations. At first, when the mismatch value is greater than the tolerance value, we will iterate it again, and when the mismatch value is less than the tolerance value, we will not iterate it again, and we will print it as an output. So that's all for now. Thanks for watching our project